Hello, in this video we'll be looking at finding the nth term of a sequence. So this is table building and writing that equation. So the first term, when it gives you a list, the first term is what shows up first. So 7 is the value of the first term. 10 would be the second, 13 would be the third, 16 would be the fourth, 19 would be the fifth. To do this, I need to go ahead and find their differences. 7 to 10 is plus 3, 10 to 13 is plus 3, 13 to 16 is plus 3, and 16 to 19 is plus 3. And if you check your x's, they're all by a factor of plus 1. That's important to do just to make sure that you're looking at them being ones. Now, when the difference is the same all around, it's what we call linear sequence. In other words, you can make a straight line from it. And all you got to do is take this number 3 right here, put it first. So 3 times the first term, so 3 times 1 gives you 3. What plus 3 gives you 7? Well, plus 4. Let's see if it holds true here. 3 times 2, that's 6. What plus 6 gives you 10? Well, that's plus 4. And if you go all the way down the chart, 9 plus 4, that'll give you 13. You're going to see that you're going to use the same second part right here to get your whole equation. So 3 times 5 and plus 4. So then I can, in theory, do 3 times 20, because that's the 20th term here, plus 4. 3 times 20 is 60, plus 4 to give me 64. So my process, my equation would be 3n, that's the term number, n, plus 4. So to figure out the coefficient of n, you look here, and to figure out the number by itself over here, you do the process to see what you get. All right, pause the video and try it out. Okay, hopefully on your own you're able to fill in this table. So let's do it. 9, 15, 21, 27, 33. I go up 6, up 6, up 6, up 6. So my number in front of the parentheses will be 6. So 6 times 1, that's 6. What plus 6 gives me 9? Plus 3. And if you continue to fill in the table the whole way, you would see that it'd be plus 3 each time. And finally, if we do 20, 6 times 20, well, that's 120 plus 3 is 123. So my nth term would be 6 times n plus 3. All right, here's a word problem. The speed with which a cricket chirps is affected by the temperature. After studying observation, the observer notices the pattern below. So if there's 5 chirps, the temperature is 45. 10 chirps and a 14-second period, the temperature is 55. 15 chirps, 65. You might notice something a little different about this. While it's true that you're looking at plus 10 on this side, the x's aren't going up by 1. Instead, they're going up by 5 each time. So if you remember back to our slope lesson, we had to do our change in y over our change in x. So 10 over 5 would actually be 2. The reason we didn't have to really do that over here is because 6 over 1 is still going to equal 6. But in this case, since the change is bigger than 1, I need to actually divide. So 2 is a number in front, times 5, well, that gives you 10. And 10 plus what gives you 45? Well, plus 35. So 2 times 10, that's 20, plus 35 is 55. Then 2 times 15, that's 30, plus what is 65? Plus 35. So n chirps would be 2n plus 35, where n, of course, is the number of chirps, and the answer you get over here is the temperature. So if you hear 32 chirps, you just say 2 times 32 plus 35. That's going to be 64 plus 35, so the temperature would be 99 degrees Fahrenheit. Thank you for watching this video on linear sequences. Next up, we'll look at quadratics.